All right, there seems to be some questions regarding how to solve trusses and a little bit of confusion. So what I'd like to do is show you the method that I use that I found works pretty well for myself and for my students. Instead of using the way that they do it in the activity, which works, just seems a little bit more confusing. I like to just do it without all the instructions all piled into one page. So I'm going to work through this truss and solve this one, and hopefully it's beneficial for some of you that have questions or just are looking for a different way to show it. The first thing that we need to do when we solve a truss like this is we need to make sure that we get all the information that we can. We can't start solving forces or anything like that until we get basic information like angles. All right, so that's always the first step, is to always solve all of your angles. Okay, and we can do this by using the lengths that are given here within this drawing. So we'll move on to this one here. I've removed all the forces and just left the distances just so that we could solve the angles. All right. The first thing that I like to do is break it down. Okay, it's just much easier to solve small triangles. The first triangle that I like to solve is this one right here. Just cut this one right here and make this triangle number 1. Okay. And then this would be triangle number 2. And then there's this big, giant triangle here. What I like to do is just cut this entire drawing right in half. Okay? Sorry that my lines aren't very straight, but I like to cut it right in half, and we'll call this triangle number 3. Now, the nice thing about doing this is that if you solve this half, all the answers are the same for this half. Okay, so if I were to cut this one here, this would be like number 1, this would be like number 2, and this would be like number 3. Just a mirror image of each half. Okay, so if we solve just this half, we'll get all the angles for this half as well. All right. Another nice thing is this right here, 2 and 3, are the same exact triangles. Okay, if you look here, the dimensions 2 by 3, this is just 2 by 3. It's the same triangle, it's just it's flipped, okay, or rotated. So we'll start here with triangle number 1, and we'll solve this guy. All right. Now, when solving a triangle, you need to know a couple different rules. And one thing that I've found is really helpful is I keep this little cheat sheet of formulas here. A triangle equals 180 degrees. A squared plus B squared equals C squared. And then you have your sine, cosine, and tangent formulas. The sine of theta equals opposite over hypotenuse. The cosine of theta equals adjacent over hypotenuse. The tangent of theta equals opposite over adjacent. Okay, and then we have some of the other formulas that we'll get into down here a little later. All right, so I usually keep a little cheat sheet like this handy so that I can always refer back to and see what I need to find. So where are we going to begin? Well, let's begin by trying to solve this angle here. All right, so this becomes theta for right now, okay, in our equation. This becomes theta, okay? So we have this length here is 3, and this length here is 3, all right? And this is theta. So we have the adjacent and the hypotenuse. So we can find out this angle using these two givens, okay? And we'll come back to the equation sheet. We have adjacent and hypotenuse. So I could use excuse me, not hypotenuse, adjacent, opposite. Sorry, I don't know why I said hypotenuse. Adjacent and opposite, this is our hypotenuse. So I have opposite and adjacent, so using the tangent formula, I can find out what theta would be, okay? And with this formula, it would say this, that the tangent of theta equals, all right, and it's going to be my opposite over my hypotenuse, so 3 over 3. Okay? Well, how do you undo the tangent function? You just do the inverse tangent function. We're going to get theta by itself. All right? So the inverse tangent, all right, of tangent of theta equals the inverse tangent of 3 over 3, or 1. I mean, that's a fraction that comes out to 1. Okay, so I'm going to do that on my calculator. This undoes this, so that's how we get theta all by itself. So we're going to find out what this angle is. All right, so I pull out my calculator here, and I'm going to say the inverse function, the inverse tangent function of 3 divided by 3, or you could just put in 1, equals 45 degrees, all right? So my angle is 45 degrees, okay? So this guy right here is 45 degrees, all right? Now the way that we do this, we all these become 90-degree angles, all right? I'm gonna draw a little box here so that you can see that this is a 90-degree angle in this triangle, all right? I'm not sure. Let's see if I can do a better job of covering. This is a 90-degree angle for this one, and this is a 90-degree angle for this triangle here, okay? Then I can come back to my little cheat sheet here, and it says, oh, look at this. All triangles must equal 180 degrees. Well, I know that I have 45 degrees. I have a 90 degree. And then I have this angle here, okay, which we'll just call, for right now, angle D, all right? Plus D equals 180 degrees. Now I can subtract. This is going to be 135 minus 135, all right? And I'm going to be left with, and I'll do it on my calculator just so you can see, 180 minus 135 leaves me 45 degrees. So D equals 45 degrees. So this one here is equal 45 degrees, okay? So I've already solved that one and that one. Now I can just update it. I know that this one over here, if it's a mirror image, this one's going to be 45, and this one's going to be 45. All right? So there we go. We have two of these triangles already solved. Now we're going to get into this one here. All right? Same exact thing. We're going to try and find, we're going to pick an angle. We'll pick this angle here. All right? This is given to us. This is 2. This is 3. All right? My opposite, my adjacent. We're just going to use tangent again. Okay? So I'm going to skip to it, and I'm just going to say theta equals the inverse tangent of, and remember, it's opposite over adjacent, so 3 over 2. So 3 divided by 2. So we'll run that through our calculator. The inverse tangent of 3 divided by 2 equals, and you get 56.3 degrees. Okay? So this guy down here is 56.3 degrees. Now we have same exact thing. Now we're going to try and solve this angle right here. Well, we know a triangle has to equal 180 degrees. So I could say 56.3 plus 90, this guy here, plus this missing one, okay, which we'll just call D again for some strange reason because I like D, equals 180 degrees. All right? Now we could subtract the 56.3 and the 90 from both sides. Okay? So 180 minus 56.3, and then we're also going to subtract another 90 from that as well. I get 33.7 degrees. So this is 33.7 degrees. All right? So let's update. 56.3 degrees. All right? This one right here is 33.7 degrees. Okay? Like I said, this one is going to be the same. This one right here, 2 and 3 are exactly the same. It's just that the angles are going to be in different places. This is going to be 33.7 degrees, and this is going to be 56.3 degrees. Okay? And I can fill it in over here. 56.3 degrees and 33.7. All right? So all the angles are actually done. And I may have jumped ahead on how I figured this out. This has got to be 90 degrees right here together. So when you add this and this, it should equal 90 degrees. All right? And then also this plus this should equal 180 degrees. Okay? So again, I just kind of flew through the geometry there. I didn't really take too long to explain it, but just wanted to be able to make sure that you knew how to solve for the angles, because that's the first step. Solve for the angles. Okay? Next thing we're going to do is we're going to take all this information and we're going to put it into a cleaner drawing. Okay? So this right here was 45 degrees. This right here is 56.3. 56.3, and you're going to see me transferring a lot of numbers. It's just the nature on how to do some of these problems. You just got to keep updating things. I'm just going to put this big angle measurement here. All right, 45 degrees here, 45 degrees here. This is 33.7. This is 56.3, 56.3. All right, 33.7. Now this one right here, according to our drawing, we have two 33.7 degrees. You can just add those together, okay? So 33.7, I'm just going to do times 2 because it's already here in my calculator, equals 67.4. There you go. So we have all these updated. We've updated our drawing, all right? Now what we need to do is go back and we need to find out what our reaction forces are, okay? If we look back at the original drawing, you'll see that we have a pin here and we have a roller here, okay? A roller only has one force going like this. And again, we don't know the direction, although looking at it sometimes we do. And then the pin, we have one going, two forces, one in the X and one in the Y. All right? I'm just going to write those in like that. Okay?